A pleasant morning to each and everyone. A pleasant morning, Miss. In this video and in this day, I want to discuss the idea of disjoint cycles. If we have two cycles that have no elements in common, so when we say no elements in common, so wala siya kapareha sa iyahang kaatbang, they are said to be a disjoint. I will show you an example. So let us consider 1, 3, 2, and 4, 6, 5. So this would be disjoint since, as I said earlier or a while ago, they have nothing in common. On the other hand, if we take a look at 1, 3, 2, and 4, 5, 3, this would not be a disjoint because they have similar, and that is the number 3 that they both have. One of the really nice properties of disjoint cycles is ang usaan na is disjoint cycles commute. So as you can see in the PowerPoint, if alpha and beta are disjoint cycles and I have alpha beta, so that's the same thing as saying beta alpha, because as long as the cycle are disjoint, we can switch the order around. So are we all clear? So nasabtan ra? Okay, thank you. We have a theorem that says every permutation is either the identity, a single cycle, or a product of disjoint cycles. And now I'm going to begin this with example since the proof follows the same technique as my example. Let's consider something in S6. So we're gonna map 1 to 3, 2 to 4, 3 to 5, 4 to 2, and 5 to 1, and 6 to 6. So let's start with 1. So 1 maps to 3, 3 maps to 5, and 5 maps to 1. Then next is 2. So 2 maps to 4, and 4 maps back to 2. So we found 2 cycles. So nadira sa ubos sa PPT. So this one as 1, 3, 5, and the other one is 2 and 4. Since the only element that we haven't looked at is 6, but it remains fixed, both of this. So I can write F as the product of 1, 3, 5, and the other is 2 and 4. Now, I have written this as a product of disjoint cycles because as we all know that disjoint cycles is they have not in common. So are we all clear? Okay, so I will not directly do this proof, but I will talk about the idea. So we must find the first element that does not map to itself. In our case on, we see that where it maps and then continue out that cycle until we have completed it. We then look the next element that we haven't already encountered, like in our example 1, 3 and 5 and doesn't map to itself. So start a new cycle and continue this pattern until we've deal with all of the elements. So we have either put them all into cycle or they remain fixed. Pareha sa 6 ganina. So let's take a look or a couple of more example of moving to disjoint. Here I have a permutation in S9. So as you can see in the first example, kaya na nata sa example 2, and I want to move it to a product of disjoint cycle. So I'm going to start with the number 1. So 1 maps to 7, no, as you can see in the PowerPoint. So so next is 7 maps to 1. So I'm done with that cycle. So manata ng 1 maps to 7. So the next number that I haven't already deal, since manata sa 1, ato na punta sa 2. With this is the 2. So ang 2 maps to 4. Then ang 4 maps to 2. So now na manata sa 1 and 2, now let's move to 3. So 3 maps to 9. So as you can see, ang 9 maps to 5, and ang map sa 5 is the 3. So I'm done. Deal with number 1, 2, 3, 4, 5. So makita ra na diha. So the next number that is 6. So 6 ang next number. So 6 maps to 8, no? And 8 maps to 6. So here we have our product of disjoint cycles. No, nakuha na to kay sa upat ka parenthesis, close parenthesis, wala siya kanaang common. So mo na siya matawag na to nga product of disjoint cycles because they don't have the same number in common. Wala siya kapareha. Now let's move on to the other example, which is example 3. So let's do more. So I'm going to start with number 1, no? So 1 maps to 9. 9 maps to 2. Nga ang 2 maps to 8. Then si 8 maps to 1. No, nakita ninyo, no? So we are done deal with number 1, 2. So let's move to 3 kay man naman ta sa 1 ug 2. So ari na ta sa number 3. Si 3 maps to 7. 7 maps to 5, and 5 maps back to 3. So na-deal na nato or nagian na nato ang 1, 2, 3 and 4. So si 4 goes to itself, deal with 5. So 6 goes to itself. So until ma-deal na to ang 7, 8, 9. So now I'm done and I have my product of this disjoint cycle. Now, let's look on taking product and writing them as disjoint cycles. So let's start with gamma 1. So gamma inverse alpha. So for an inverse, we just need to switch the order. So instead of 2, 4, 3, 1, 5, I would have 5, 1, 3, 4, 2. And then alpha is 3, 7, 1, and 4. So let's start with 1. And once again, we need to move from right. So always remember now, we need to move from right to left. So 1 maps to 4 and 4 maps to 2. We then look at 2. So we see that 2, kay maps man siya sa 5, we now consider the number 5 that this remains constant here. So 5 maps to 1. So I've completed the cycle. I've already looked at numbers 1 and 2. So let's look at number 3. Atong pangitawon ang si number 3. So 3 maps to 7, and then that 7 remains constant. So 7 maps to 1, and 1 maps to 3 siya. So we are done there. So now I have deal with 1, 2, 3. So let's look at 4. So si 4 maps to 3, and 3 maps to 4. So actually, dili na ni siya kinahanglan since it will remain constant. So I've already deal with 5 and 6, so remains constant Japon na siya, and I have 7 also. So that's why I've completed the inverse alpha. So next, let's look at beta inverse gamma. So beta inverse would be 3, 2, 1. And the gamma, as you can see in the PowerPoint presentation, it is 2, 4, 3, 1, 5. So let's begin. So 1 maps to 5, and the 5 remains constant. So 5 maps to 2, then 2 maps to 1, so we are done there. Now, let's move on to 2, or let's start with the number 2. So 2 maps to 4, and then the 4 remains constant also. So 4 maps to 3, and 3 maps to 2. So 4 would map back to 2. So ang atong buhaton ani, it's only number nga I haven't encountered is 3. So we say that 3 maps to 1 and 1 maps to 3. So 3 actually remains constant. So this would be the disjoint cycle that represent B in inverse gamma. So that's all, and thank you for your time and for listening, and I hope that you learn something from this discussion. Thank you so much again, and God bless us all.